So, which of these is the bounciest of all? So, what I did was I took three different balls and I bounced them from 200 centimeters and just recorded the data. So, which one of these appears to be the bounciest? Now, for bounciest, I would assume that it would bounce back to the highest height after you drop it. So, I'm looking here, C is definitely not going to be it. And then between A and B, it looks like B is bouncing more. The rebound height is higher. So ball B has a higher rebound height. So for each expression, write an equation expressing the bounce height after bounce N. So in this problem, so for A, we'll have to do a little bit of work. We'll go 110 divided by 200. And I got 0.55. And then our initial height is 200. So the bounce height is going to be H is 200 times 0.55 N. And then for ball B, to get our bounce back height, we would go 140 divided by 200. And that's about 0.70. So you can see it has a higher bounce back rate. So H, our initial height is 200 times 0.70 to the number of bounces. And then for ball C, to get that rate, we'll go 60 divided by 200. Which is 0.3. And then our height is 200 times 0.3 to the N. So explain how the equations can tell us which one is most bouncy. So the most bouncy ball has the higher growth factor or decay factor. So in this case, it has a highest decay factor, which is 0.70. So if the bounciest one were dropped from a height of 300, what equation would model it? So here, we would just say height equals. If I change my initial height from 200 to 300, we would just write 300 times the bounce rate would be the same, so 0.70 to the N.